questions 11 through 20 of the 1997 grade 10 Cayley math contest is what I will cover in this video. In the chart, the products of the numbers represented by the letters in each of the rows and columns are given. For example, xy is 6, xz is 12. If x, y, z, and w are integers, what is the value of xw? So basically what they're saying is that x times z is 12, which is what they give you, and x times y is 6. So we have to somehow figure out w and then multiply x by w. So this is really just trial and error, plug in some numbers, see what you get. If we put x as 6, then z must equal 2, right? Because x times z is equal to 12. Now, on this side here, if xy is equal to 6, which is what they gave you here, and we've already put x as 6, then y must be 1. And for w, zw right here, or wz, is equal to 50. Because the products are what these numbers represent. So z we've already said is 2, so w must be 25. So let's see if these numbers actually make everything work. xy is 6 times 1, that works. zw is 2 times 25, which is 50, that works. And then let's look at the columns. xz is 6 times 2, which is 12. And finally, y and w is 1 times 25, which is indeed 25. So that all works. So the question then finally asks us to find x times w. Well, x is 6, w is 25, and therefore 6 times 25 is 150. So the answer here is A. 3 small rectangles of the same depth are cut from a rectangular sheet of metal. The area of the remaining piece is 990. What is the depth of each cut? So the cuts are right here. I'll draw them in red. That's the depth of each cut, right? And they're saying all of those cuts are the same depth. So I'll call each depth or each cut x in terms of its length. Now, what is the total area of the shape before the cuts were made? Well, that's just length times width. And the length is 80, and the width is 15. Therefore, the total area is 1200. Now, they've cut out these rectangular shapes. So we have to figure out the area of those rectangular shapes. The first one here, length times width, would be just 5x. The next one here would be 15x. And this shape that's cut out is another rectangle, and it's 10x in terms of its area. So this totals 30x. So the remaining piece is essentially the total area minus 30x, which is 1200 minus 30x, and they have told you that that is equal to 990. So solving for this, you get 210 is equal to 30x, x is equal to 7. And that is essentially what they're asking in the question. What is the depth of each cut? I had chosen x to represent the depth of each cut, and I calculated x to be 7. So the answer is B. Triangle ABC is a right-angled triangle with AB equal to 10, AC equal to 8. If BC is 3 times DC, then AD equals. First thing I'm going to do is draw this out a bit bigger. And I'm going to start filling in the information. So that's a right angle. This is equal to 8. This is 10. And this is D. And this is B. Now they've told you that BC is equal to 3 times DC. So for example, if DC was X, this whole BC is equal to 3x. Okay? So, looks like we have a whole bunch of Pythagorean theorems here. And this is A. So let's first do the Pythagorean theorem on the big triangle, which is ABC. And that would give us BC, which is 3x squared, plus this part here, AC, which is 8 squared, is equal to 10 squared. So that means 9x squared is equal to 100 minus 64. 9x squared is equal to 36, and x squared is equal to 4, therefore x is 2. So this x is equal to 2. Now we can just use Pythagorean theorem on this triangle to figure out AD, which is what the question is asking. So DC is x squared plus CA, which is 8 squared, is equal to AD squared. X is 2, so that becomes 2 squared, which is 4. 8 squared is 64, is AD. And therefore, AD is equal to the root of 68. And that is choice E. The digits 1, 2, 3, 4 can be arranged to form 24 different 4-digit numbers. If these 24 numbers are then listed from smallest to largest, in what position is 3142? Okay, so they've already told you that there's 24 numbers. So if you were to write out all 24 numbers, you'll quickly notice that the first 6 all begin with a 1, like that. The next 6 will begin with a 2. There'll be numbers of that form. And the next 6 will begin with the number 3, like that. And of course, the final 6 will begin with the number 4, like that. Now, we don't really need to worry about what these numbers are, nor do we need to be concerned with these numbers. We just need to concentrate on these ones, because these are the ones that begin with the number 3. So we can quickly write them out. 3124, 3142, 3214, 3241, 3412, and 3421. Now, are these in order in terms of smallest to largest? And I believe they are. So that's good. So that means that this number, remember, these are the first 6, these are the next 6. This is therefore going to be the 13th number. And this number is the 14th number. And that is the number that they were asking us about. So the answer would be B. The product of 20 to the power of 50 and 50 to the power of 20 is written as an integer in expanded form. The number of zeros at the end of the resulting integer is. Okay, so this is going to involve some number manipulation here. So what we're trying to achieve, our goal, is that we want to get as many 10s as possible. And those 10s are going to tell us a lot about how many zeros are there. So that's the first thing I did, is I broke this up into 2 times 10 and 5 times 10. And that would immediately give us a whole bunch of 10s, like this. And you can group these 10s together, and they would become 10 to the power of 70. So you're left with 2 to the 50 times 5 to the 20. Like that. Now, can this be further manipulated to create more 10s? And the answer is yes. You can bring this 2 over here to match the exponent on the 5, like that. And when you do that, this becomes a 10. 2 times 5 is 10, and it's all to the power of 20. You can do that when the exponents are the same. Well, that's good because now this further lets you create more tens. This now becomes 90. And this is essentially 2 to the power of 30 times 10 to the 90. Well, 2 to the power of 30 is some big long number. It's not really important what it is, but I'll just write it out. Some very, very large number. And then followed by 10 to the 90. So essentially, you've got all these zeros. 0, 0, 0, just keeps on going. And they're asking, how many zeros are there? Well, it's 10 to the 90. So there's 90 zeros. And let's see, what is that? It's choice C in this question. A beam of light shines from point S, reflects off a reflector at point P, and reaches point T, so that PT is perpendicular to RS. Then X is. Okay, first thing I'm going to do is draw this out a bit bigger. And I'll label this now. We got T here, we have S, this is 26, this is X, and this is P up here, this point right here, and this is R. The trick to this question is drop a perpendicular down like that, from T continuing down to the base, RS. And then this becomes a right angle. Now, what's this angle in here? Well, that's also X. And the reason that is X is because it's a vertically opposite angle. And the rule is that vertically opposite angles are the same. So if you look at this, this and this essentially create vertically opposite angles, and they therefore must be the same value. So now the good news is that you've got enough information in this triangle here to solve for X. And we basically have the same equation as we always do with triangles with regard to the angles, is that the sum is always 180. So we've got 180 equals 26 plus 2x plus 90, because remember this was a right angle. And if you solve for this, you get 2x is equal to 64, and therefore x is equal to 32. So that would be choice A. In the diagram, adjacent edges are at right angles. The 4 longer edges are equal in length, and all of the shorter edges are also equal in length. The area of the shape is 528. What is the perimeter? Okay, the longer edges that they're referring to, I believe, are here. These are the longer edges. And the shorter edges that they're referring to are these ones. All of these shorter edges here. So let's give them some values. Let's call the longer edge X, and we'll call the shorter edge Y. Now what I'm going to do is I'm going to break this shape up into different smaller squares, like that. And the hope is that when you draw it out like that, you can see that this shape is essentially a whole bunch of identical squares put together. And if you count the number of squares, there's 33 of them. And each square, based on what we've labeled, has a side of y. So the area of each square is y squared. So therefore, 33 squares is equal to 528, which is what they told you in the question. And since each square has an area of y squared, we can solve for y. So y squared is equal to 528 divided by 33, which is 16. Y is equal to 4. Now look back at the diagram. We also need to figure out what is x. And based on this diagram, we can clearly see that x is equal to 3y. And therefore, x is equal to 3 times 4, which is 12. Finally, the perimeter, which is what they're asking for in this question, is 4 of these x's, right? Because this is x, and that's x, and then a whole bunch of y's. And if you count the number of y's, you'll see that there's y's all around the shape like that, all across the perimeter. And the number of y's is 24. So now all we have to do is plug in our values for x and y, and we should be able to get the perimeter. X is 12, y is 4. So we've got 48 plus 96, and that equals 144. So the answer is E. If 30 over 7 is equal to this set of variables, where x, y, and z are positive integers, then what is the value of x, y, and z added together? So this is going to involve a lot of algebra here, so let's just do this without making any mistakes. It's essentially just a bunch of fractions, but instead of numbers, we've got letters. So if you get a common denominator, you're going to have to multiply top and bottom by z, like that. And then this will be 1 over yz plus 1 over z. And then you invert and multiply, so you get z over yz plus 1. Bring that over here. And we need a common denominator, yz plus 1. Multiply top and bottom. And we'll have finally z over yz plus 1, like that. So we've got xyz plus x plus z all over yz plus 1. So that is our final equation, and that's equal to 30 over 7. Now, does that help us in any way? Well, let's look at the bottom. Let's look at the denominator. We have yz, this one right here. Yz plus 1 is equal to 7. So that means that yz is equal to 6. That's about as far as we can go. Now let's look at the numerator. We've got xyz plus x plus z is equal to 30. Now we can plug this in here. So that gives you 6x plus x plus z is equal to 30. And therefore we have 7x plus z is equal to 30. So these are our two equations that are going to help us solve for x, y, and z. And remember, all three have to be positive integers. So if y times z is equal to 6, the only possibilities in terms of integers are 1 and 6, 2 and 3, 3 and 2, and 6 and 1. So now what we have to do is plug these values back into here to figure out x. And then really what we're doing is plugging the value for z. If you do that for z equal to 6, you'll get x equal to 3.4. Now that's not going to work because x has to be a positive integer. If we plug in 3 for z, you will get 3.8. So that's no good. If you plug in 2, you'll get x equal to 4. And that indeed is a positive integer solution. 4, 3, and 2 for x, y, and z. Now what is the question asking? What is the value of x plus y plus z? Well, x was equal to 4, y was equal to 3, and z was equal to 2. So x plus y plus z is 4 plus 3 plus 2, which is 9. And that would be choice B. If x squared yz cubed is 7 to the 4th and xy squared is 7 to the 5th, then what is xyz? Okay, initially it probably seems a bit daunting, but what I immediately noticed is that if you combine both of those, you'll get something very interesting. So here you got x squared yz cubed is 7 to the 4th, and then the other relationship they give you is that xy squared is 7 to the 5th. So if you multiply this by this, you will see that this will help us out tremendously. So if you do that, you get x squared yz cubed times xy squared, and that equals 7 to the 4th times 7 to the 5th. Well, what does this become? It becomes x to the 3rd, y to the 3rd, z to the 3rd. And this becomes 7 to the 9. Remember, you add the exponents. So then what you can do is you take the cube root of both sides because you just want xyz. So xyz, 3, 3, 3, like that. You just take the cube root. And similarly, you would have to do that to the same, you'd have to do the same to the other side. And this would essentially just give you xyz. And then this right side becomes 7 to the power of 3. And that's all this is. Pretty straightforward if you multiply both of them together. So the answer is C. On a circle, 15 points, A1, A2, A3, all the way up to A15 are equally spaced. What is the size of angle A1, A3, A7? So first of all, what are they asking us? We have to make that clear. This is A1, this is A3, and this is A7. So you have to draw an angle like that. That's what they're asking. They're saying, what is the value of this angle right here? A1, A3, A7. Okay, so I'm going to draw this a bit bigger, but first I want you to understand that each of these has a distance from the center to the edge of the circle, right? Like that, each of these. And therefore, each of these smaller ones is going to have a number in terms of its angle size, and they are equally spaced. So all of these angles here are the same. So how do we figure that out? Well, the total sum all the way around is 360. And then how many of those smaller pies did we make? Oh, how many slices, I guess? Well, we made 15 because it goes up to A15. So therefore, each of these is equal to 24 degrees. So this is 24 degrees, that's 24 degrees, and so on. Okay, so that's very important. Now what I'm going to do is I'm going to draw this much bigger to explain it better. And what I'm really going to concentrate on is just A7 to A3, A3 to A1, and then the distances to the center. So I'm going to draw that, essentially. So let's do it. Let's draw that out. Okay, so that's what I drew, exactly like what's on the circle in red, but I drew it a little bigger here. And now I'm going to label it. So this is A7, this is A3, and this is A1. And this is the center of the circle. Now I'm also going to put in A2 right here, and I'm going to put in A4, A5, and A6. And I'm going to draw the lines, or distances rather, from the center to each of these A's. like that. Okay? Now, do you remember what is the angle size for each of these? It's 24. So that's 24, that's 24, that's 24, that's 24, and so on. Okay? Now, what are we trying to find? Remember, we're trying to find A1, A3, A7, which is this angle right here. A1 to A3 to A7. Okay? So how do we do that? Well, one thing that I immediately noticed is that this is the radius of the circle. The center to A1 is the radius. And similarly, if you draw a line from the center to A3, that's also the radius. So therefore, this is an isosceles triangle. So this angle is the same as this angle. Okay? So we can use the relationship of those angles to figure out x. So 24 plus 24 plus 2x is 180. And therefore 2x is equal to 132, x is equal to 66. So we've got half the puzzle solved. Now we turn our attention to this triangle, right? And it's basically the same thing. You want to understand that this is a radius and this is a radius. So therefore this is also an isosceles triangle. So if this angle, say, is y, this angle will also be y. So just like we did with the previous triangle, we have to figure out y, and we do that. All of these are basically 4 times 24 plus 2y is equal to 180. So if we solve, we get 2y is equal to 180 minus 96. 2y is equal to 84, and therefore y is equal to 42. All right? So this y is equal to 42. So the last step is trying to figure out this whole angle here. Well, that whole angle is essentially x plus y. X is 66, y is 42, and therefore this is 108. So the answer here is D.